All right. Welcome to section 4.6. We're going to talk about complex numbers today and operations with complex numbers. So our essential question, how can we perform operations with complex numbers, and what information will it give us for quadratics? If you want to take a look in your book, there are some real-life examples of things we could use complex numbers for. That's on page 277. But the properties that you do need to know for this section, if r is some positive real number, then the square root of negative r equals I times square root of r, and I times square root of r squared just equals negative r. So up to this point in our math career, we've said that if you have the square root of a negative number, there are no solutions. And that's kind of true. There are no real solutions. And that's where these properties of imaginary numbers come into play. So let's look at an example. We want to solve 5x squared plus 33 equals 3. Step 1, subtract 33 from each side. Step 2, divide by 5. And then step 3, take the square root. So up until this point, we've said, because we're taking the square root of a negative, there are no solutions. Now we're going to change that a little bit. We're going to put the number I in front of our square root, then write this as square root 6. Six doesn't contain any perfect square factors, so we can't simplify the square root of 6 anymore, but just like with square roots that we've looked at before, you still have two solutions. It's positive and negative, I times square root 6. For this second question, again, same first steps. Subtract 18. Divide by 2. And then take the square root of both sides. So we're taking the square root of a negative number, so that means we automatically have to write an I in front of our square root. And when we write the I, now we have a positive number underneath the radical, and we can just factor and simplify. So 45 does contain perfect square factors, or factor. And the biggest perfect square that we have is 9. So we can rewrite this as I times square root 9 square root 5. Square root of 9 is 3. So we want to write the integer before I. So this would become 3I and then square root 5. All right, so part of our essential question is performing operations with imaginary or complex numbers. So I think it helps to go in and look for what is a rational number, something that I've seen before. Okay, 12, seen that before. Negative 8, that one makes sense. Just like when we talk about combining like terms, we're going to do that same thing here. Those rational numbers can be added together. And then look for the complex or the imaginary numbers. I see minus 11i. I see plus 3i. You can think about I as the exact same thing as an x as far as combining like terms go. If you have two complex numbers, you can add or subtract them together. But I cannot combine the 4 and the negative 8 because 4 is rational and negative 8i is complex. So to write the final answer, we would say that this is the same as 4 minus 8i. And you could take this one step further and factor out a 4, but it's not necessary. Let's look at another example. Look for the rational numbers. Add them together. Look for the complex numbers. Add them together. And then simplify. Or write the sum. And again, here you could factor out a 3 also. This works for subtraction also. $15 minus 24. We get negative 9. And then negative 9i minus negative 9i. When we subtract a negative, that's like adding. So then here we have negative 9i plus 9i. So that equals 0. Because negative 9 plus 9 is 0. So this one turned out nice. It just became negative 9. And then for this next example, we don't see the parentheses, but it's still going to be the same idea. And I think it'd be easier if you kind of distribute the negative sign before we simplify. So this will become 35 minus 13 minus 4i plus I. Then again, the rational numbers can be added together or combined. And then the complex numbers can be combined. So the final answer is just 22 minus 3i. When we multiply complex numbers, if you take I times I, that's the same thing as I squared, which is the same thing as the square root of negative 1 squared. And anytime you have a square root that you're squaring, the square root goes away, and then we're left with negative 1. So anytime you have I times I, it always equals negative 1. All right, let's look at some examples. For this question, we have negative 5i times the group 8 minus 9i. So if it's helpful, you can rewrite this using the box method. You'll just have one row and two columns. Otherwise, you can just distribute. That'll work too. Well, you can combine the rational terms. So 8 times negative 5, that makes negative 40. And then I can't be multiplied with anything else for our first term. So it's just negative 40i. Then we have negative 9i times negative 5i. So negative 9 times negative 5 makes 45. And then I times I is I squared. And on that last slide, we said if we have I squared or I times I, that always equals negative 1. So 45i squared is the same as 45 times negative 1, which is negative 45. So then when we write our final answer, negative 40i squared can't be simplified any further. And then negative 5 is what we were able to simplify negative 9i times negative 5i to. And it always, you want to put the rational number first. It's good form. So negative 45 minus 40i. And to show you what I was talking about with distributing, you can take the I on the outside, multiply by both terms on the inside. We said I times I always equals negative 1. Subtracting a negative becomes addition. So this is the same as 1 plus 9i. If we're multiplying complex binomials, you can think about this as something, like pretend the I is an X. We've seen that before. You do the box method, multiply everything out. Now we're just kind of changing the value of what X is. And this time it's not X squared. It becomes negative 1 because it's I squared. So I'm just going to write out both terms. Negative 8 plus 2i. And then 4 times negative 7, or 4 minus 7i. Multiply each box out. Negative 8 times 4, we get negative 32. 2i times 4 is 8i. Negative 8 times negative 7i. Negative times negative is positive, 56i. And then we have 2i times negative 7i. So 2 times negative 7, we should get negative 14. And then I times I makes I squared. And then we said, if you have I times I, or if you have I squared, that equals negative 1 every single time. So this is the same as negative 14 times negative 1, which becomes 14. So now we can combine the rational numbers. Negative 32 plus 14 to get negative 18. And then 8i plus 56i. We should be getting 64i. And then negative 18 is rational, 64i is imaginary. So all we can do is write negative 18 plus 64i. All right. Here's part 1 of your video. Next, we will talk about conjugates.